vector is ai cap, OB vector is aj cap, and OC vector is ak cap. From three conterminous edges of a cube, and S denotes the surface of cube, then we need to evaluate this integral by expressing it as a volume integral. So we are going to use the Gauss's divergence theorem over here. So let V be the region enclosed by the surface S, and F vector is given to us. For the Gauss's divergence theorem, we need to find out the divergence of F vector. So that is the dot product of this with F vector, which is equal to derivating x cube minus yz with respect to x minus derivating 2x square y with respect to y plus derivating 2 with respect to z. So that is equal to 3x square minus, this is 2x square and this is 0, so that gives us x square. So now using the Gauss's divergence theorem, the surface integral of dot product of F vector with N vector equal to the volume integral of the divergence of F vector. So that is equal to the volume integral. What is the divergence of F vector? We have just calculated. This is x square. And for dv, I'm writing dx, dy, dz. And because these are given to us, so what are the limits for x, y, z? It's from 0 to a, right? So 0 to a, 0 to a, and 0 to a. Separating them. And we get this to be x cubed divided by 3 with the limits. And this is y with limit 0 to a. And this is z with limit 0 to a. So putting the upper limit, we get a cubed divided by 3 minus, putting the lower limit, we get 0 into, this is a and this is also a. So that gives us a the power 5 divided by 3 as a surface integral, right? And now we are going to verify the result by direct evaluation of the surface integral. So the surface of the cube is given to us, and F vector given to us is x cube minus yz I vector minus 2x square y j vector plus 2k vector, right? Now this surface cube consists of 6 faces. So we are going to evaluate the surface integral over these 6 faces. So let's first calculate the surface integral over this face, that is OBNA, right? So this is the surface integral, writing F vector and its dot product with N vector. N vector is the unit outward drawn normal to the surface, this one, right? So this is your z-axis. So this unit outward drawn towards the negative z-axis. So that is N vector is equal to negative k vector. So this is minus k vector ds. So this is equal to the surface integral, that is the double integral, as we are having ds over here. So when taking the dot product, we get minus 2. And as this surface is on x and y axis, so this is dx dy, right? And the distance of this a point from the origin is a, and also the distance of this b point from the origin is a, right? So the limits of x is from 0 to a. The limits of y is also from 0 to a. So first integrating this with respect to x, we get minus 2x and limits from 0 to a. Still we need to integrate with respect to y also. So this becomes minus 2a, right? And now integrating with respect to y, we get minus 2ay from 0 to a. So when putting the upper limit, we get minus 2a square and then minus 0. So we are getting this to be as minus 2a square. Marking this as 1. And now calculating the surface integral over the surface PLCM. That is this one. And the unit vector drawn, and the outward unit vector drawn normal to the surface PLCM is along the z-axis, the positive z-axis. So here n vector becomes k vector, right? So this n vector is k vector. So this is equal to the double integral. When taking the dot product, we get 2 ds. So ds will be now For this surface, we take ds to be again dx dy, right? So this is dx dy, and the limits for x is from 0 to a, and the limit of y is also from 0 to a. So integrating 2 with respect to x, we get 2x from 0 to a limits. Still we need to integrate with respect to y. So this becomes 2a minus 0. And when integrating this, we get 2ay from 0 to a. So when putting the upper limit, we get 2a squared. Marking this as 2. And now calculating the surface integral over the surface OBLC, that is this one. And the unit outward drawn normal to this surface is along the negative x-axis. So n vector is minus I vector. And for this surface, we are taking ds to be equal to dy dz, right? So here n vector is negative I vector. So this is equal to the double integral. When taking the dot product, we get x cube minus yz with negative sign, and ds is dy dz. And the limits of y is from 0 to a, limits of z is from 0 to a. Now for the yz plane, x is 0 because the plane is yz, right? So taking x equal to 0 over here, we get double integral of yz dy dz from 0 to a limits. Very fine. Okay, separating them, integrating y with respect to y, we get y square by 2 with limits from 0 to a. Integrating z with respect to z, we get z square by 2 with limits 0 to a. And when putting the limits, we get a square by 2 minus 0. And here also a square by 2 minus 0, that becomes a the power 4 divided by 4. Marking this as 3. And now over the surface NPMA, that is the opposite of this surface, this one. And here unit vector drawn normal to the surface, this is along the positive x-axis. So n vector is I vector, right? And taking ds to be equal to, yes, same, dy dz. Or you can remember this, when the unit vector is along whatever may be the x's, just take the product of other two x's, right? If it is along the x-axis, take ds to be dy dz. If it is along y-axis, then take ds to be dx dz, right? So this is equal to the double integral. Limits, we know that from 0 to a, and n vector is I vector this time. When taking the dot product, we get x square minus yz, and ds is dy dz. Now for the surface PNAM, what is the value of x? It is constant, that is a. For this surface, x is 0, right? But for this surface, x is a. So taking x equal to a here. So for x equal to a, we need to integrate a cube minus yz. Now integrating with respect to y first. This is a cube y minus y square z divided by 2 with limits 0 to a. So that is a the power 4 minus a square z divided by 2 dz from 0 to a integral. And now integrating with respect to z, we get a the power 4z minus a square z square divided by 4 with limits 0 to a. So putting z equal to a first, we get a the power 5 minus a the power 4 divided by 4. Minus, putting the lower limit, we get 0. So the required answer is up to this only, marking this as 4. And now integrating over the surface OCMA, and the unit vector drawn outward to this surface is along negative y-axis. So n vector becomes negative j vector. And ds becomes, yes, because the outward unit vector drawn is along the y-axis, the negative y-axis, we are taking ds to be dx dz. So this is a double integral, and n vector is negative j vector. And when taking the dot product, we get These two are having the negative sign, so we get 2x square y, and ds will be dx dz, limits from 0 to a. Right? Now for this surface, y is 0, right? Because this surface is for the xz plane. So y is 0 here. That is, the integrand is 0, which means we are getting this surface integral to be 0. Y is 0 on OCMA. Now over the surface BLPN, that is opposite to this surface, and the outward unit vector drawn normal to the surface is along positive y-axis, so taking n cap to be equal to j cap, and the constant value of y is a on this surface, right? And for this we take ds to be equal to, the unit vector is along the y-axis, so taking ds to be dx dz. So for BLPN surface, n vector is j vector, and this is double integral. When taking the dot product, we get negative of 2x square y, and ds will be dx dz, and the limits from 0 to a. On this surface, the constant value of y is a, right? And on taking y equal to a, the integrand becomes negative 2x square a, right? So this is equal to negative of, okay, integrating this with respect to x first, taking 2a outside. So this is negative 2a, the integral of, okay, integrating x square with respect to x, we get x cubed divided by 3, limits from 0 to a, and dz. When putting the upper limit, we get a cubed by 3 minus the lower limit, that gives 0. So this is a cubed by 3, taking this 3 outside, and also a cube is taken outside. So this is a the power 4, and we need to integrate 1 with respect to z. So that is equal to minus 2a the power 4 divided by 3. Okay. Integrating 1 with respect to z gives z from 0 to a. Putting the upper limit, we get a minus the lower limit, that is 0. So this is a, that is minus 2a the power 5 divided by 3. Marking this as 6. And now we are going to add all these 6 integrals. The complete integral of dot product of f vector with n vector over the surface S. So that is equal to, first integral gives us the answer to be minus 2a square. Then is plus 2a square, that gives 0. Minus 2a square plus 2a square, right? Then third and fourth integral, that is a the power 4 by 4 and a the power 5 minus a the power 4 by 4. And then the last two, fifth integral is 0, and sixth one is negative 2a the power 5 by 3. So this is equal to, cancelling these two, we get a the power 5 minus 2a the power 5 divided by 3. So that gives a the power 5 divided by 3